These are the practice problems for lesson 3, balanced moves. And this is problem number 1. So you're given this hanger diagram. It says the weight of the triangle is x. So the weight of this triangle, these triangles, each has a weight equal to x. And the weight of the square is y. So each of these squares have a weight of y. So if I fill that in, I'm going to label the number of squares and x's with the coefficient here. So I have 1x plus 3y's. So this is 1x plus 3y's. That is equal to 4x's on this side plus 1y. Now usually when the coefficient is 1, you drop that coefficient because it says how many x's do you have? You have 1x. So you just write that as x. So the equation is x plus 3y equals 4x plus y. And it says if x is 6, so this value of x in every case is equal to 6, then what is the value of y? So I'm going to replace, in the equation, I'm going to replace the x's with 6. So x is 6, and x is 6 here, and 4 times 6 is 24. So now we have 6 on this side plus these 3 y's equals 24 on this side plus 1y. So now I want to get rid of that 1y. So I'm going to just cross this out on the hanger diagram. So that's going to be 1y here. And you're going to be left with 2y's over here. So it's 1y gets crossed out. So y plus negative y. So algebraically, you would add a negative y. So you add its additive inverse. That becomes 0. It's like crossing this out right here. You're left with 24 on the right side. So this is 24. And if you cross out one of these y's, again, that's like adding negative y. So 3y plus a negative 1y equals 2y. So now you have 6 plus 2y equals 24. So 6 plus 2y, and the value that you have on this side is just 24 now. So now I want to get rid of that 6 right there by adding negative 6. Well, on the hanger diagram, just cross it out. So that gets crossed out. You cross out one of these, and you're left with left with 18. 3 times 6 is 18. So 6 plus negative 6, that becomes 0. So you're left with 2y equals 18. 24 plus negative 6 equals 18. So now you have 2y equals on this side 3 of these x's, which are equal to 18. So you combine all those together. You divide those evenly between the 2 y's, and 1y then equals 9. So 2y equals 18. Well, half of that, 1/2 of 2y is 1y. Then you have to, that is equal to 1/2 of 18. 1/2 of 18 is 9. So you end up with an answer of y equals 9. For problem number 2, you have a pair of equations, the given equation, and then the result of the first step. And that first step is one of these choices over here. So how do you go from this equation to the first step, this equation to its first step, this equation to its first step? By using one of these moves. So you're supposed to match them up. So I'm going to change, for A, I'm going to change subtracting a positive 3 into adding a negative 3. So I'm going to use the inverse operation and the additive inverse to change this to addition. And in doing that, you notice that the 9 doesn't change and the negative 3 does not change. So that gives you a hint that it's probably getting rid of this 4x by adding a negative 4x. And so you have to add a negative 4x to this side over here, and this becomes 2x. So 6x plus a negative 4x equals 2x. So the answer for A is number 4 over here. Add negative 4x to both sides. For B, they're getting rid of this factor right here by multiplying by negative 1/4. So negative 1/4 times negative 4 equals 1. So that gets rid of that negative 4 as a factor. And also, 4 5/10 is the result of multiplying negative 18 times negative 1/4. So this is the opposite. So negative 1/4 times negative 18 is the opposite of 1/4 times negative 18. And the opposite of that is a positive 18/4. A little bit tricky here. So you have to realize that a negative times a negative gives you a positive because it's the opposite of a negative. It's a positive value. So that's 18/4. And you can look at it as at 18/4 as 16/4 plus 2/4. 16, and the reason I want to do that is 16/4 is 4, and 2/4 is 5/10. So it's a little bit easier for me to see that this is 4 and 5/10, and that's the result of multiplying negative 18 times negative 1/4. So B is number 1. Multiply both sides by negative 1/4. C, I'm going to change subtracting a positive 10x to adding a negative 10x in both cases. And you see that that does not change and the 5x does not change. So that means that you're probably adding something to both sides, not multiplying. If you're multiplying, then all these terms would change. But since you're adding, and you're adding only a negative 4, so this is 8 plus negative 4 is positive 4, and 7 plus negative 4 is positive 3. Usually you entirely get rid of one of these terms. For example, add a negative 7 to get rid of this 7, but in this case they're just doing part of it. You usually wouldn't do that, but it's okay. They're just showing you a balanced move to get from this equation to this equation. So the answer for C is to add a negative 4 to both sides right here, number 5. D, you have to look a little bit more closely at this term right here. What are different ways that you can write negative 5x divided by 4? So negative 5x divided by 4, you could factor out the negative 1 and write this as a negative 1 times 5x divided by 4. You can move this negative 1 outside the entire fraction and write this as negative 1 times 5x divided by 4. And you could move this 4 in the denominator out and make a fraction of a negative 1/4 times 5x. And it is this form that they're really using to multiply negative 4 times a negative 1/4. This equals 1. And so you're left with 5x. That's this 5x right here. And I think the best way to explain these different forms right here, is that you're really using the commutative property to move these factors around. So look at this as 4 factors. Negative 1 times 5 times 1/4 times x. And these different forms are just using the commutative property to move these around. So negative 1 times 5 times x, all of that divided by 4, that's this one. Negative 1 times 5x divided by 4, that's this one. A negative 1/4, so negative 1 times 1/4 is a negative 1/4 times 5x, that's this one. And there are several other ways that you can write this. And using the commutative property, once you see that, then you can see that a negative 4 times, there's a negative 1/4 that's kind of hidden in here, and that gives you the result of 5x. Negative 4 times a negative 1/4 and then times 5x equals 5x. And that equals negative 16. So negative 4 times 4 equals negative 16. And so that's number 2. This is a positive 5x, and this is a negative 16. So that's number 2. Multiply both sides by negative 4. A little bit hard to see. And think about this a little bit. And the last one, this is an example where, since they're using multiplication, every term changes. You have to multiply every term by this 1/4 to get 3x plus 1 equals 5x plus 6. So 1/4 times each one of these terms gives you this equation. You can also look at this as factoring out the 4. So if I factor out 4 from 12x plus 4, I'm going to get 4 times 3x plus 1. And if I factor out 4 from 20x plus 24, I'm going to get 4 times 5x plus 6. So this is 20x divided by 4 is 5x, 24 divided by 4 is 6. And then I can multiply both sides by 1/4. Same answer, multiply both sides by 1/4. And then I'm going to get this 3x plus 1 equals 5x plus 6. So multiply both sides by 1/4, and you get this equation right here. 3x plus 1 equals 5x plus 6. For problem number 3, Andre and Diego are each trying to solve this same equation. And the way that Andre does it, he ends up with this equation as a first step, and Diego ends up with something different. He ends up with this as the first step. And so what is the first move? What's the first move that each of them makes to get this equation for Andre or this equation for Diego? The first thing I'm going to do is change subtracting a positive 8 to adding a negative 8. I always like to change everything to addition. And so now, if you look, you can see that what Andre did is he removed this 3x from the right side. So you're left with this negative 8. So he removes 3x on this right side, whereas Diego removes the 2x from the left side. So he gets rid of this 2x and is left with 6 equals x plus negative 8. So for Andre, 2x plus 6 equals 3x plus negative 8. If you add negative 3x to both sides, you're going to get rid of this 3x right here. So this becomes 0, and you're left with 2x plus a negative 3x equals a negative 1x. So this becomes negative x plus 6 equals negative 8. Probably want to stay away from a negative x if you can, and actually that's what Diego does. Diego says, well, I'm going to take the same equation, but I'm going to get rid of this 2x on the left side. That's going to leave me with a positive x on the right side. 3x plus a negative 2x equals a positive 1x. So 6 equals a positive x plus negative 8. And the way to look at that is choose the side that has the least number of x's and subtract those x's from that side. That will leave you with positive x's on the other side. Now you could, once you're at this point, you might be able to see that this is x is going to equal positive 14. On this side, a negative x is going to equal negative 14 because you're going to subtract, or you're going to add a negative 6 to this side and negative 6 to this side. If you have a negative x equals negative 14, then you can multiply through by negative 1 and turn that into x equals positive 14. So x equals positive 14, and you can get this to eventually the same thing, x equals positive 14. If you have negative x equals negative 14, then the opposite of x is going to equal positive 14. That's another way to look at it. This is problem 4. And in this problem, I went way beyond what the problem is asking for. So let me just show you first the minimum of what you're supposed to do. And you're supposed to fill in this table. I'm going to show you how to do that in just a moment. But you fill in the table, and then you figure out the slope of the line. You plot those points from the table and figure out the slope. And the way that you would do that, usually given the points and the line, and usually you can just count. And I'm going to show you a bunch of different ways to look at this. But let's first go through the first part. And I'm going to separate these, by the way, with this pink slide. All right, so let's go through this. To figure out these points, I'm going to start with the given x values. So if you plug in for x2, what you're going to do is multiply every value of x gets multiplied by 3. And then you add its additive inverse to 15, and that tells you what the value of y is. So 3 times 2 is 6, and 15 plus a negative 6. So the additive inverse of a positive 6 is negative 6. So 15 plus a negative 6 is 9. 3 times 6 is 18. So there's the 6. 3 times that 6 is 18. 15 plus a negative 18 is negative 3. 3 times 0 is 0. 15 plus negative, well, actually 0 has neither positive nor negative. So 15 plus 0 is 15. And 3 times 3 is 9. 3 times that 3 right there is 9. So the additive inverse of 9 is a negative 9. So what you're doing each time is you're removing this term from this side of the equation to get the value of y. So 15 plus a negative 9 is 6. All right, so those are when you're given x, you multiply it by 3, add the additive inverse, and that gives you the value of y. But what if you're given y then? Well, if you're given y, you add the additive inverse of y to 15, and then you take 1/3 of that. Remember, you have to get rid of this coefficient right here. So you're going to multiply by 1/3. So if y is 3, so 15 plus a negative 3 is 12, and then 1/3 of 12 is 4. So 1/3 of, you have 3x equals 12, and 1/3 of 3x is x. So then you have to figure out what's 1/3 of 12 is 4. If y is 0, 3x, then 3x equals 15, and 1/3 of x is 1/3 of 15, which is 5. So x equals 5. And finally, if y is 8, so 15 plus a negative 8 is a positive 7. So now we have 3x equals 7. 1/3 of that 3x is x, and 1/3 of 7 is 7/3. And then you plot each of these points. So this is the x-coordinate, this is the y-coordinate, this is the x-coordinate, this is the y-coordinate, and so on. So plot each of these points on a graph. Oh, let's just review just for a moment. So this equation right here can be rewritten. This is called the standard form. So 3x plus y equals 15. And we looked at balancing parts of problems before using the standard form of the equation. You can rewrite this equation into what's called the slope-intercept form or the y-intercept form by figuring out what y equals. So you're going to add a negative 3x. So this is y is equal to negative 3x plus 15. And when you do that, the coefficient of this x is the slope. So the slope is going to be negative 3. So when you figure out this slope down here, we have to get negative 3. And this graph is going to cross the y-axis at 15. That's the y-intercept. Remember, that's the b part. So this is, we looked at some problems where we said, oh, you're already starting with $15 or 15 units, whatever it might be. So that b said the beginning, and remember we looked at the slope as the movement. You're moving a negative 3 units for every 1 unit in the x direction. You're moving a negative 3 units in the y direction. All right, so let's just use 2 of these points to figure out the slope before we even look at the graph. So one point is 4, 3, and the other point is 2, 9. So you're going to subtract the difference. You're going to find the difference. It's as if, so you want to find the length along the x-axis and the length along the y-axis. And so you subtract from where you started. So if I started at 2, 9, if I start at this point and I went to this point, maybe I should show you on the graph. Yeah. Then what I'm going to do is subtract the beginning amount. It's as if you begin with $3 and you end with $5 and you ask, well, how much money did you make? You subtract the beginning amount. 5 minus 3 equals $2. But what if you begin with $5 and you end with $3? Then you subtract also. $3 minus the $5 means you lost $2. That's negative 2. So it's the same idea. I'm going to subtract the beginning point, which is going to be 2, 9, from the ending point, which is going to be 3, 4. And I'm going to go into this in a lot more detail later on. So 3 minus 9, subtract where I started. So 3 minus 9 and 4 minus 2. I'm subtracting this beginning point. So 4 minus 2. So I started with $9. I ended with $3. That means I lost $6. I started with $2. I ended with $4. That means I gained $2. So that ratio of those amounts is a negative 3, which is the same slope as up here. So negative 6 over 2 is the same as negative 3. All right, and so what the authors more than likely expect you to do is to graph the points and find 2 convenient points to just figure out the slope by counting. So if I go from this point to this point, Actually, if I go from this point to this point, it makes a little bit more sense. So I'm going to go up here a positive 6 units. So that's positive 6 units in the y direction and a negative 2 units. So negative 2 units in the x direction. And notice it's the same slope. The slope has to be negative 3. So that ratio of positive 6 to negative 2 is negative 3. So it makes a difference where you start and where you end. So if I start here, I'm going to go positive 6, and I'm going to end here, negative 2. And we'll look at that in just a moment. So this is really where the problem ends. This is all you really have to do. When we calculated the slope before, we used the movement of slope triangles to visualize, to see what was happening as we were making that calculation. So this is the same calculation that we just did. What we did is we started at this point, 2, 9, and we moved to this point, 4, 3. So this was the ending point, and this was the beginning point. And so to figure out the slope, you take where you started, the 2, 9, and you subtract that from where you ended, because you want to figure out what's the length along the x-axis and what's the length along the y-axis. Well, if I started at 9 and I ended at 3, it's like starting with $9 and ending with $3. I'm going to subtract these $9 because that's what I started with, but I ended with this positive 3. So that means I actually lost $6. So I'm at a negative 6 along the y-axis. So this length is a negative 6 units. But along the x-axis, I started at 2 and ended at 4. So how much did I gain? I actually gained $2 if it's money that we're talking about. So this 4 minus this 2. So this point now is down to here, but now it's going to slide over 2 units in this direction. This whole triangle is going to slide over 2 units because it's this 4 minus this 2. We start at 2 and we ended at 4. So now 4 minus 2 is 2. So this point right here is 2 units in the positive direction along the x-axis and 6 units in the negative direction along the y-axis. So its length is positive 2, negative 6. And so now the ratio along the y-axis to the length along the y-axis to the length along the x-axis is this negative 6 over a positive 2. Negative 6 over a positive 2 equals negative 3. So you get this negative 3 as the slope. Now, rather than starting at 0.29 and ending at 0.43, what if you start at 0.43 and end at 0.29? What's the calculation look like then? So I'm going to start at 0.43 and I'm going to end at 0.29. So now I'm going to subtract where I started from where I ended. So that means it's going to be 9 minus 3. So if you started with $3, for example, and you end at $9, that means you gained $6. So this is a positive 6. If you started at $4 and ended at $2, that means you lost $2. So this length is negative 2. So you're going to get a positive 6 over negative 2. So once again, if I started at $3 and I ended at $9, 9 minus 3 is I gained $6. But if I started at $4 and ended at $2, 9 minus 4 is negative 2. So that ratio between the movement along the x-axis compared to the movement along the y-axis, it's a negative 3 for each unit along the x-axis. So 6 divided by negative 2 is negative 3. Now, this is set up so that this point right here, xy, 4, 3, is being subtracted from 2, 9. So here's the 2 and the 9 for that point, and that's where you end, and you're subtracting where you start. Now you can make this calculation for any 2 points along this line. So let's do this a couple more times. So let's say that we started at this point, 6, negative 3, and we ended at 4, 3. So how do I know this is where we started? Because that's the amount that's being taken away. You're subtracting where you start from where you end. No different than starting at $3 and ending at $5. So you subtract where you start, the $3 from where you end, the $5, and you end up at positive 2. It's the same idea. So I started at 6, negative 3, and I ended at 4, 3. So I'm going to subtract 3 minus this negative 3. So I'm going to subtract where I started, negative 3. So I started with negative $3. I was negative $3 in the hole in debt. And I ended up $3 in having $3. So I'm not in debt anymore. So what did I have to have done? I had to have gained $6. This is a positive 6. But on the other hand, for the x-coordinate, I started at 6 and I ended at 4. So that means I lost $2. 4 minus 6 is $2. So this point right here is going to slide up here. I'm going to I'm going to subtract negative 3, which is an increase of 3 units, and it's going to slide over here 6 units. So this slope triangle is going to go up to here and over to here, because the starting point, you always want to get the starting point to this origin. So once again, I start at negative 3, 6. So for the y value, it is start at negative 3, ended at 3. So 3 minus a negative 3 is positive 6. I started for the x coordinate, I started at 6. I ended at 4, so I actually lost $2 of its money that we're talking about again. So that ratio, 6 divided by negative 2, is the slope, negative 3, and again, it has to equal negative 3. So let's try this with a few more points and see if you can't start to visualize what's going on as that slope triangle moves. Let's do this with 0, 15, and 6, negative 3. So where am I starting? Well, I'm subtracting the starting amount, which is 0, 15. So I'm starting at this point right here, 0, 15. So here's the 0 for the x-coordinate and the 15 for the y-coordinate. So if I started at 15 and I ended at negative 3, I lost money. So how much money did I lose overall? If I had $15, I ended up owing $3. That's a negative 3 minus 15. That's a negative $18 that I lost. On the other hand, in the x direction, if I started with $0 and I ended with a positive $6, that means I gained $6 in the x direction. So that ratio, negative 18 to 6, is negative 3. So let's look at that movement one more time. I started here at 0, 15, and I ended here at 6, negative 3. All right, so I'm going to subtract this 15, these 15 units from this negative 3. So I'm going to, it's like adding another negative 15. So this is going to slide down 15 units, which makes this entire length negative 18 units. But at the same time, so this all slides down. So this point slides down to here. But now I ended up at positive 6 along the x-axis, where I started with 0. That means I gained $6, or if it's money again that we're talking about. So this is going to be at 6, negative 18. So this length is 6 units. That's what you're calculating. 0 minus 6, I'm sorry, 6 minus 0, this length is 6 units. Negative 3 minus 15, or plus a negative 15, this length is a negative 18 units. So it's negative 18 over a positive 6, which again gives you this calculation of the slope of negative 3. Let's try one more time. What if we use this point, 7/3, 8? So a little bit harder because of this fraction for the x-coordinate. So we're starting here. This is what's being subtracted, this 7/3, 8. This is the x-coordinate, this is the y-coordinate, from this coordinate, this point at 0, 15. So if I start at 8 and I end at 15, that means I gain 7 units in the y direction. So this triangle, you're going to subtract this 8, you're going to end up at 7 units, but I lost 7/3 units in the x direction because I started at 7/3 and I ended at 0. So that's 0 minus 7/3. This 0 minus the 7/3. So I actually lost 7/3. So take a look at what that looks like. So I started at 7/3, 8, which 7/3, by the way, is 2 1/3. So I started here and I ended up here. So I'm going to subtract where I started. So I ended at 15, but I started at 8. So I'm going to take this 15 units and I'm going to subtract the 8. So this is going to slide down. This is going to slide down to here. And this length right here, from this 8 to 15, you're going to see that this is a positive 7. And then this point is going to slide over here. So it's 0 where you ended minus where you started. 0 minus 7/3. So this is going to slide over here, the whole thing, the whole triangle. So sliding down to here. Then it's going to slide over here. So this point is going to end up right here. So this point is going to end up out here at negative 7/3. So start at 8, end at 15. So that means you gained 7 units or $7. Again, if you're talking about money, you started out at 7/3, you end up at 0. That means you lost 7/3. So that ratio of how much you gained along the y-axis and how much you lost along the x-axis is 7 to negative 7/3, or 7 divided by negative 7/3. So you multiply by the multiplicative inverse of negative 7/3, which is a negative 3/7. These 7's cancel, and you're left with a negative 3. You can look at this as the opposite of 7 times 3/7, which is the opposite of 3, which is a negative 3. And again, you have to get this negative 3 as the answer. That is the slope. So it's a nice way to check. All right, so once you have figured out the slope, and we did this multiple ways, how do you figure out this equation? Y equals negative 3x plus 15. Well, you use one of the points, and I'm going to use this point right here, 4, 3, and that's the starting point. And I'm going to subtract it from any other point on the line. And we're going to call that point xy. So to figure out this length along the x-axis, you have to, along the y-axis, you started at 3, you ended at y. So you have to subtract these 3 units. So this is y minus 3. So that's going to tell you the length along the y-axis. And you started at 4, and you ended at x. So you have to subtract these 4 units. That's going to tell you the length along the x-axis. That ratio, the length along the y-axis to the length along the x-axis, has to equal negative 3, because that is the slope. So every unit along the x-axis gets multiplied by negative 3 to figure out the length along the y-axis. So along the x-axis is a negative 3 times that length along the x-axis to figure out this length along the y-axis. So now you can use the distributive property. This is a negative 3x plus a positive 12. A negative 3 times a negative 4 is a positive 12. And this is plus a negative 3. So you add a positive 3 to remove this negative 3 right here. And so a positive 12 plus a positive 3 is positive 15. And you already have the negative 3x on this side. So this equation has to match this equation up here. Now I'm going to go through this in even more detail in a moment so that you can see how this is working with the movement of a slope triangle. I was interested in showing how to come up with the equation for this line and showing the movement of slope triangles as you do that using a couple different points. So using this point here and this point down here. And what I'm going to show you is movement from this point to this point and how to write that equation, or movement from this point to this point and how to write that equation. And so I'm going to go through briefly how I chose these points, how I proved that this was 2. I'll go through all this slowly. I could have selected other points. I didn't have to choose this point right here. I could have selected a few other points. And then going through writing the equation in each direction. So how do you do that? And then matching the movement of the slope triangle. So I'm going to change this to x and y and movement of the slope triangle. So why does this blue slope triangle, so I'm moving this point, this is the beginning point, this is going to 0, 0. Why does this blue slope triangle match this equation? Well, if this is the starting point, then to figure out the equation, it is 11 minus y, so it's 11 minus y, so you subtract where you started, and 4/3 minus x, 4/3 minus x, and again, I'm going to go through this in way too much detail. And why does this red slope triangle match this equation? Again, I'm moving this point right here to the origin, so that means this is the starting point, so I'm going to subtract y minus that starting point, which is 11, so y minus 11, and x minus 4/3, which is the starting point, x minus 4/3. So I'm going to go through that in a lot of detail, and you end up with these two equations. This is the equation for the original line, y equals a negative 3x plus 15, and this is the equation for just the proportional part right here, y equals a negative 3x, y equals a negative 3x. And you see that this is parallel because it has the same slope to this line, but every point on this line up here is always 15 units more than its corresponding point down here because it's plus 15. You add 15 every single time. The idea is to use 2 points on this line and to show how you write the equation for this line, as well as to show the movement of the slope triangle as you're writing that equation. So I'm going to choose 2 points. I'm really going to focus in on this point right here, 1 1/3 and 11 along the y-axis, or as the y-coordinate. So how do I get there? First of all, I just chose 4 1/3. I said I'm just going to go out here to 4 units plus another 1/3. And I want to prove to you that the y-coordinate for x equals 4 1/3 is 2. So if you plug into x right here, 4 1/3, so it's a negative 3 times negative 3 units for every unit along the x-axis, and there's 4 1/3 units, so it has to be a negative 3 times that 4 1/3. Well, 4 1/3 is the same as 13/3. So negative 3 times 13/3, this is a negative 13. You can look at this as the opposite of 3 times 13/3. These 3's cancel out. You're left with positive 13. The opposite of a positive 13 is negative 13. And so 15 plus that negative 13 gives you this 2 right here. So then how do you get to 1 1/3 and 11? So I just decided I'm going to go backwards 3 units. So from 4 1/3 in the negative direction 3 units gets me to 1 1/3. So this point right here is 1 1/3. This point on this line up here is 1 1/3. So what's the y value? Well, I could go through, plug the 1 1/3 into this equation again, but I don't have to do that. I know that this length has to be a positive 9 units, because if this is negative 3 units, the length in the y direction is a negative 3 times the length in the x direction. So it's a negative 3 units in the x direction. So what's a negative 3 times negative 3? That is equal to positive 9. So it has to be positive 9 units along the y-axis. Well, if this is positive 9 and I start out at 2, this is 2 units. This is 2 units right here. And add 9, you're going to end up at 11. So this point right here is 1 1/3, 11, and this point right down here, right here, is 4 1/3, 2, which is the same as 13/3, 2. Now I could have chosen other points. I didn't have to choose 1 1/3, 11. Let's say that starting at this point, I decided I'm going to go in the negative direction 2 units. Well, negative direction 2 units, that means along the y-axis, it's a negative 3 times negative 2, which is positive 6. That has to be positive 6 units in this direction. That would be this point right here. And you might remember that on this graph from the table, this point is 7/3, which is 2 1/3, 8, which is 6 units plus these 2 units. So it gets you up to 8. I could have chosen to just go 1 unit in the negative direction, so that would be 4 1/3 to 3 1/3. So but a negative 1 unit, what's the length along the y-axis? It has to be a negative 1 times a negative 3, or the opposite of negative 3, which is positive 3. So this point right here would be at 3 1/3, 1, 2, 3 1/3, and positive 3 plus 2 would be positive 5. So positive 5 here, or I could have chosen to go in the positive direction, and I said, well, what's it going to be if I choose to go to this line right here, which is 1 2/3 units plus 4 1/3. So 1 2/3 plus 4 1/3 gets me out to 6 units. But if I'm moving this direction, 1 2/3 units, or 5/3, that means I have to move in the negative direction along the y-axis, a negative 3 times 5/3. Well, negative 3 times 5/3 is the opposite of 3 times 5/3, which is 5. The opposite of 5 is negative 5. So this is a negative 5 units in this direction. So this point out here is going to be 6, and it's negative 5 units. So it's 1, 2, 3, 4, 5. And you might remember on the table there was a point that was at 6, negative 3. So that's that point right there. And I might have overdone this a little bit, a little too confusing. The point is, just have to choose a point and go from there. And there's many choices to use. To write the equation, you can start either at this point, 4/3 11, and move to xy. And I'm going to call this point right here xy. So I can start here and move to this point xy, or I can start at xy, wherever it is along here, and move to this point 4/3 11. If I start here, this is the beginning point. I'm going to subtract these two coordinates from x and y. So it's going to be y minus 11. So I have to get rid of these 11 units to figure out what this length is. So that's y minus 11. And I have to subtract these 4/3 units to figure out what this length is along the x-axis. So it's going to move this point right here down to here. So this is going to be y minus these 11 units. So it's going to drop this down to here. And x minus these 4/3 units. So it's going to move this point over to here. So this length along the y-axis, wherever you are, is going to be y minus these 11 units. And the length along the x-axis, wherever you are, is going to be x minus these 4/3 units. But on the other hand, if you choose to start at xy, somewhere down here, and move to 1/3 or 4/3 11, then you're going to subtract x and y from this 4/3 11. So it's going to be 11 minus the units for y. So it's going to be 11 minus y, because you want to figure out what this length is. So you have to take 11 and you have to subtract whatever the y value is. And it's going to be 4/3, this 4/3 right here, minus x, because you have to take these 4/3 units and subtract whatever this length is along the x-axis to get this length. And in either case, that ratio, the length along the y-axis divided by the length along the x-axis, is going to be negative 3. So if you work through this is y minus 3. That length along the y-axis is a negative 3 times the length along the x-axis. And likewise over here, this is the length along the y-axis. It is a negative 3 times the length along the x-axis. You use the distributive property, negative 3x plus a positive 4. So this is a negative 3 times a negative 4/3. That's a positive 4. Or a negative 4. So negative 3 times a positive 4/3 is a negative 4 plus a positive 3x. Negative times a negative is a positive 3x. And you add a positive 11 to both sides. So add a positive 11 here, and you get this to be positive 15. So this is the equation, y equals negative 3x plus 15. Or if I added a positive x to this side to get rid of this, which would be plus a negative y, positive y, which would be plus a negative y, so that moves this y over here. And I added a negative 3x here to get rid of this positive 3x, that moves this negative 3x over to here. Add 11 plus 4, you have to add positive 4 also. So 11 plus 4 is 15, and negative 3x. So you get the same equation. Y is equal to negative 3x plus 15. Okay, what about the movement of the slope triangles? And this might make this a little bit more clear. So again, I'm going to change this coordinate right here to x and y. And I'm going to move the blue slope triangle first. So I'm going to move this coordinate right here, this point right here to the origin. This means this is where I'm starting. So I'm starting at x and y. So I'm going to, if I want to figure out this length right here, I have to subtract 11 minus the value of y is, whatever this value is. So this is going to be 11 minus y, 11 minus y, and it's 4/3 minus whatever this value is to get to this x coordinate here. So 4/3 minus this value right here, whatever that x value is. So it's 4/3 minus x. So that's going to move this slope triangle to here. And so this slope triangle matches this equation. On the other hand, if you start at 1/3 or 4/3 11, if you start here and move to this point, it's going to move this coordinate down to the origin. So in this case, you're going to have to subtract 4/3 11, this coordinate, from x and y. So it's going to be y minus 11. So you have to take away or subtract these 11 units right here to slide this down 11 units down to here. So this is y minus 11, and then you have to slide this slope triangle over to here by subtracting this 4/3, or 1 1/3. So it's y minus 11 over x minus 4/3. So y minus 11 slides it down here, the whole triangle slides down here, and x minus 4/3, the whole triangle slides over to here. And again, you work through this, and so you figure out that this red slope triangle has to match this equation, because this one is starting at this point right here, and it's ending here. So it's going to be where you end, subtracting where you start. And this is problem number 5, and it says select all the situations for which only 0 or positive solutions make sense. So it has to be either 0 or positive. So in the first case, measuring temperature in degrees Celsius in the Arctic. So it gets really cold up there, so the temperature can go below 0. So the first case can have a negative answer. So that doesn't fit. Second one, the height of a candle as it burns over an hour. You cannot have a negative height of a candle. It's going to burn down to 0 height. Can't go below that. So B fits. The elevation above sea level of a hiker descending into a canyon. So going down into a canyon. If it's a canyon somewhere, you can go below sea level. So you can have a negative elevation because you can go below sea level. So C does not fit. The number of students remaining at school after 6 o'clock, you can't have a negative number of students. So D fits. D has to either be 0 or positive. A bank account balance over a year, you can go into debt. You can have a negative bank account balance. So E does not fit because it can be negative. And F, the temperature in degrees Fahrenheit of an oven used on a hot summer day. So if it's really hot outside, it's not, the temperature of that oven is not going to go below 0. It's going to start wherever the temperature is on that hot day, and it's going to increase. It's going to go above. It's going to be positive. So F, D, and B are all situations in which the answers can be only 0 or positive.